Metamorphism is caused by changes in the heat, changes in the pressure, and changes in circulating fluids, hot water that gets in there and changes up the mineralogy. You don't have to have all of that at once to have metamorphism, but you need at least one, and sometimes they all occur at the same time. Rocks can be overprinted by multiple events. You can have one metamorphic event, time passes, and then another metamorphic event. Just depends on the tectonics at that time. Causes, the first one we'll go over, turn my face off here. See that pretty rock? So there's some kyanites and some garnets. The first cause here is the change in heat. Most of the metamorphism is going to occur between 250 degrees Celsius and 850 degrees Celsius. What's happening during that change is that heat is going to break bonds and then reform new bonds. So it changes the mineralogy and changes the textures. That heat can come from different sources. It may just be the geothermal gradient, that the earth gets hotter the deeper you go. It could be from a magmatic intrusion. So the country rock gets metamorphosed because of an intrusion. Or it could just be heat from compression. That squeezing of the rocks can generate heat. The depth at which it's going to happen is going to be dependent on the plate tectonic setting. The pressure in the earth increases with depth, and that pressure is going to take atoms and squeeze them and pack them in more tightly and create denser materials as you go deeper into the earth. So these images here show garnets and biotites that have grown during metamorphism because of pressure. We looked at this image earlier, this graph. It is the phase change between Andalusite, kyanite, and sillimanite, and it is about what pressure and temperature are those minerals stable. So the pressure and temperature are both changing with depth in the earth. It gets hotter and the pressure gets higher the deeper into the earth. So this diagram shows those polymorphs, andesite, sillimanite, and kyanite, and where they are stable, what conditions. Andalusite at the top of the graph likes low pressure and low temperature. A kyanite likes low temperature and high pressure, whereas a sillimanite is more likely to form during high temperature and high pressure. So that tells you if you see those in a rock, then those are the conditions at which that rock was metamorphosed. Okay, differential stress. Turn my face back on here. That's all about squeezing. So the example here is a house of cards and stepping on those cards and they flattening out. The image on the right is an image of the Linville Gorge. See the layering there in the rocks? That's foliation, and that has occurred because those rocks were squeezed, and the micas have aligned themselves. It would be like this. The micas have aligned themselves perpendicular to that stress, that compressive stress. Differential stress. So we can shear the rocks. We've taken a stack of cards and shear those cards. The normal stress would just be like this, and the shear would be like this. Okay. The shearing motion and those differential stresses can create these texture changes. So here's that preferred orientation and the alignment of those mica grains. Here are some images of shearing. So we've got in the first image round, maybe quartz crystals and some rod-shaped crystals that are not oriented in any particular direction. Maybe those are actually muscovites. And then we shear that rock and we start to align the long axis of those quartz crystals. They start to elongate, become more oval shaped. So we start with the round crystals. We can shear them over, or we can just flatten them and just squeeze them and directed pressure. Circulating fluid, so hot water has a way of dissolving ions and moving them around. And so it makes metamorphism happen faster, and the chemical reactions happen faster. We can add and subtract ions into the system with the circulating fluids. Circulating fluids, there's a special name for that kind of metamorphism. It's called metasomatism. So if it's occurred by fluids, it's metasomatism. Okay, foliation. Foliation comes from the Latin word folium, which means leaf. And these are the alignment of those crystals to form planar fabric. And so here is a nice in my hand and in that image down below. And these are banding. This is banding, but it's a preferred orientation. And in this case, it's a compositional banding as well.